this is Prod9, a library I developed and I continue to work on. Now it's about 7 years, and it is really, really popular. And maybe sometime when, if any of you are aspiring data scientists, you may get to use it, or something like it. I do develop and maintain other libraries. For example, there's that one, Mizani, which is, it does something called scaling. When you are taking data from an external source and you want to visualize it onto a small screen, you have to reduce the world it is coming onto the small screen that it is. And then also you have to be able to map aspects of the data. For example, if you have an age range, so something like 15 to 20, and you want to map those to colors, you need a color scale. And this is what a library like Mizani does. It maps information to something that it helps you map. It creates scales that help you map information to aspects that you can visualize. And there are others. No, like that. But the topic is what is data science. Now, these are two familiar words, and I don't know if any of you can define data science. Do I have any takers? What do you understand data science to be? Anyone? No takers? Okay.
So my take on data science, I break it down into two terms, data and then science. Data being processed information, right? So that's when you get information in its raw form and then you clean it and, you basically take it through the whole process. It becomes, instead of it being raw facts, it turns into data, meaning you can get meaningful information from it. The science is basically, I would say, dissecting or breaking down that data to get meaningful insights from it.
I think we can leave. She's done my job for me. Now, there is a disconnect between being able to define something and being able to understand it. And it is easy to define, but hard to understand. And we are going to work our way towards a definition of data science, but it is close to what Mercy has just has been able to kind of like telegraph to us. But most important is the understanding of what data science is, and she kind of like could tell where I was going, and we're going to break down these two words, data science. But if you look at them, we have data and science, but one of them is more important than the other, and it is science. What is science? Years, we, or even more specifically I, regurgitated that until when I was sure I wouldn't be asked for the definition on an exam, and then we stopped hearing about what is science. Then that is moving over to secondary school. But the problem with secondary school is you get to the sciences, and they come one after the other. You get physics, you get biology, you get chemistry, you get all these things. But the good thing, there was no definition. None of those were defined. The primary definition for science was meaningless, and as a person who looks towards, who is very curious and interested in understanding, I was lost, and I didn't know what to expect. As in, how can we just start studying these things without knowing exactly what it's about? But with time, I got to understand what science means. And the more I got to understand what science means, the more I got comfortable with not living by a definition of it, and being able to appreciate just understanding of it. But then afterwards, I came up to, this is a good definition, but I don't think I would have understood it. For example, like in primary 2, because to understand the definition of science, we have to go along the journey that science has brought to us. As in, we don't just wake up and have science, but that is what happened as a country that did not participate in the development of these ideas. And as you will find out, no one country participated in the development of all these ideas. They all come in at some point, and it is up to us to understand where they are coming from and what they mean, because without understanding where they are coming from, we make colossal mistakes, and I'll share one of them. So, science. Scientists originally used to, or not just scientists, people originally relied on their senses, and it's the first thing we do. If you go to someone in a rural area, you rely on your senses. You have the sense of, you have sight, you have smell, you have taste, you have hearing, you have touch, and we process these senses. You add your brain, you process these sentences, and then you come to a conclusion. And that conclusion, or that knowledge that you come to, serves you well. But as the society starts developing and people get free time, they start asking more of questions of the world, because you have enough. Society is efficient. People no longer have to work with their hands. They no longer have to spend time in the fields. You have a class of people who basically go out to seek knowledge, and the next thing they realize is that their senses are not enough to figure out the world they live in, that their brain is more important than the senses. For example, we have the sense of sight, but what we see, that is called the visible light, the visual spectrum is just a minute bit of the whole spectrum of light. As you can see over here, we have visible light taking up the smallest fraction. If you're looking at it this way, on your left, you have the high energy and dangerous, high frequency, high energy and dangerous, high wavelength, low frequency and dangerous, and then on the other side, on the left, where you have infrared and radio waves, you have that is the low energy. And in between the high and the low, what we call the high and the low, is the small slice that is the visible spectrum. Now, this visible spectrum, looking at it this way, is interesting, because we exist in a world with a lot of information coming at us, and I want to point out just one thing over at looking at this slide, and maybe some of you have gotten those messages on social media warning you about something like, 5G, this thing is going to be dangerous and everything. But here is something, here is a food for thought. 5G, or all radio telecommunications, take part to the other side of the visible spectrum, on the low energy side. So if that is causing problems for you, that means the light bulb, the people you see are also causing problems for you, because the technology for communication is way on the other side of what is considered dangerous. Now that is sight. And to see something, we have to, whatever object you see has to reflect enough light particles into your eyes. So if it's small, there won't be enough surface, so you start thinking of a Microsoft. If it's far away, the light gets lost in a way by minute particles in the atmosphere. So if you look up in the night sky, what you see is not really what is out there. If you want to get a better sight of what is there, you go climb the mountains where there's less air pollution, less light pollution, and you'll see a night sky that is invisible to us city dwellers. And now let's get to another side. Smell. Smell is the nose has sensors that basically detect molecules of air and send the signal to the brain, and you register smell. But it is also not perfect. It has its limits. Not all molecules will be detected by the sensors in the nose. For example, you have carbon monoxide, a gas that will instantly kill us within 5 seconds of you taking a breath of pure carbon monoxide. You will die. Yet we cannot smell it. And the reason for that is that it was not a constant presence in the environment in which man evolved. So when man was coming up, when it came to the sense of smell, if something was dangerous, the body evolved to sense it in a way that is in a turn-off way, so it smelled off. If something was good, fruits and whatnot, they got a pleasant sense, as in it. So we call it. So these days we call it a scent, as in it's good, it's rewarding. But obviously there are exceptions to that. Then you have taste. Taste is kind of similar to smell, but for the sensors on the tongue, they interact with liquid, not just gas. And it also has its limits. But one thing to note about both of these, smell and taste, is that they are chemical sensors. The smell is picking out chemicals in the air, and taste is picking out chemicals in liquid. So if you suck in air and dry out your tongue and put anything on it, you will not be able to taste it. Once you mix that with saliva, give it some liquid, and the taste buds will pick it up. So both of these are chemical sensors, as in this is chemical sensing, smell and taste. And then we have hearing. Hearing is the body creating a surface to pick up pulsations in air. In pulsations, these are vibrations of air, as in poof, one vibration, poof, 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 and constantly you get something that vibrates a surface. We call the eardrum, and the eardrum is also interesting because it has its limits. It has a spectrum of hearing. If the signal is very low, the pulsations, the vibrations are very low, you will not hear anything. If they are once they cross a certain limit, you start damaging the surface. You start damaging the eardrum, even just living alone damages the eardrum. For example, there are well-known frequencies. I think one is let's go there. Now, the Greeks were interesting people. About 600 BC, they got ideas. And the world in which they lived did not allow them to express their ideas. As in, if they did not feel comfortable expressing their ideas because the only framework of ideas was religion. And you don't come in and change religion. This is not what God does. They fear them. No, I don't have to add towards the Greek gods and how ferocious they are. So you don't come in and respect it. You come in, you learn it, you observe it, you die, and it more or less goes along, changing very little each generation. You know, and it changes a lot, but changing very little each generation. But they wanted something, so they said, okay, we are going to restrict our thinking to phenomena we can observe. We shall leave religion, we shall not mess with religion, religion remains separate, and we shall go on parallel. Because at this point in time, we live in a world where their civilization had developed, whereby you had a class of people who could spend time thinking about these things and did not have to go and man the fields, they did not have to work with their hands, so they could put their brains to intellectual pursuits. So they started thinking about observable phenomena, and they started creating these wonderful ideas about the world. But the problem with these ideas is that they would conflict with the ideas of other people. So they were coming up with ideas, but they had no way, no framework of thinking about how to verify their ideas. And this thinking is the back of what we call philosophy. Philosophize about it. I'm sure that word comes of many of you, but it is at the root of where we're going. And about 200 years after the coming, so there we're looking at 400 BC, 350 BC, around there. So a math that kind of developed. We had some guy actually in that time. No, they had an experience of developing an alternate thinking system, and then they came to something interesting to them. Logic. They're like, now, with religion, we have a problem. The problem of no ideas. You can't bring your ideas to religion, but you have a lot of time to think and philosophize. But with philosophy, you have ideas and disagreements, and there's no way to resolve these disagreements among people. So we here in this greater school of thinking, state of the ground up, we start thinking in this way, we get ideas about how the world is formed, how matter is constituted, and these people also here, they start with another set of principles, they come up with their own ideas of how the world is created, how matter is constituted, and these two would never agree. So they saw the problem in that, and they chanced upon something else, and that something was logic. Now, logic came in, say, after 200 years. Logic, they call this equivalent to them. It means something like valid reasoning. And the reason why that word is evocative of the situation is that they realized that philosophy was not valid reasoning. If two people cannot come to a conclusion, you cannot come to a definite conclusion about the state of the world, then and you cannot tell who is right and who is wrong, then you have a problem. We have a problem, but we didn't know how to solve that, and they discovered this system called logic. And logic was simple, as in you have to agree, as in there are premises. Someone says, let's say this is called room A. Someone says everyone in room A is alive, and Hassan is in room A. The definite conclusion is Hassan is alive. So they built a whole system of and mapped out all the things you could say in the logical system. And on the side, it's still going to be the philosophy, but they be like, this logic was separate. It was valid reasoning, as in you could not mix. Yes, philosophy maybe they have to develop and get something, but they had logic. Now, the Greeks then, they got this logic, mathematics, and philosophy, and they passed them onto the Romans. The Romans got them, safeguarded them. They did little with it. For about safeguarded for about 1,000 years, they did little with it. They did add a lot. They did take away. They just safeguarded for 1,000 years. Basically, nothing little like philosophy, but logic, nothing math, zero. And when the Roman Empire collapsed in the West, you had it in the East going on, and they transformed those three to what were the early Islamic Empire. Now, those ones got them, and at the time, they built up a civilization centered around that. You got a class of people who didn't have to till the land, they didn't have to work with their hands, they had enough time to go to these things, and they made improvements in math, logic, and philosophy. But then, time went on. Their society faced problems, and Western Europe came up from the ashes of what is known as the Dark Ages. Now, the Dark Ages simply means that the empire, the imperial empire that brought all this information had retreated, and the people did not have the systems to stay up with developments in the world. So they were having inventions, they were not writing letters. Societies that were 80% literate now became like 2% literate. So that is what they mean by that. As in, the Roman Empire in Western Europe collapsed, we went to their architecture failed, we had buildings go to ruin, and had this downward. But after some years, they rose up. And when Western Europe came up, it inherited these three things. They inherited logic, mathematics, and philosophy. They got some of it. They got from the Rome. They got some of the little bit that the Islamic Empire had added, and they got to work because their societies also achieved that status, whereby in the 15th century, 15th, 16th, 17th. They also developed to a point whereby you had the same phenomena, a class of people who did not have to work with their hands, and they had enough time to develop to thinking and putting their brains to work. So what they did is that they realized the flow in the inadequacy of logic. They realized that they appreciated it. They realized mathematics and philosophy, and they went to work a lot with philosophy. Because as we spoke earlier, as I noted earlier, that the stuff that was in philosophy, we could not agree about it, we could not form a one around it. You had to do something about it, and what we call this rehabilitation as in mark your way around the topic that in a way that describe the just and stay with what makes sense. And this rehabilitation basically had one core idea. If there is evidence for it, and you can prove it, then it is part of the philosophy we want to practice. So anything without evidence, anything without proof, we do not want to do that. And this is the question. This is the part of what we call the scientific method. Without understanding the scientific method, you cannot appreciate science because it was a struggle to get to the point. And the scientific method is responsible for everything we have in our modern world. It is responsible for the developments in the knowledge that this microphone, the camera, almost everything. Probably not the bricks that built this, But the factories that make them definitely owe a lot to the scientific method. It is a careful system of study and publication of results. If you understand that and you internalize that well enough, then you are really good data scientist. So that brings us to the definition of science. Science having gone through all that, we can say, now this is not very definite, we can say science is coming to a conclusion or realization backed by evidence and sound reasoning. And this is what it takes, to understand this is what it takes, I would term it as being scientifically literate. Scientifically literate is the only requirement to be in the data science. But that is a hard step. It is the biggest requirement to be in the data science, because if you do not know how to avoid the mistakes that our brains so easily make, or the errors that are prevalent in the ways we collect data, in the ways we handle it, in the ways we chain together our concepts and ideas, then whatever is the output of your analysis and thinking, it is going to end up with errors. So, with that, we come to what we were looking at. What is this? Oh, I need power.
Which type?
C, yes. Sorry, Massey. Now, Massey gave us an interesting definition of data science. He could basically see this slide before we even got there. And this is what we've been building up towards. We can say data science is the practice of gaining accurate insight from recorded information. Yes, it is. Is that agreeable? Was it worth the journey? Does that, given what we have learned, given what we have gone through, do you find it strange that we come to that conclusion? And does that definition make sense without what we have gone through? Anyone?
I think it does. I got to about the part of the philosophy, this argument, right?
Yes.
I think I think if we have recorded information, but importantly, I think the key word is accurate insights, right? So if we have that accurate insights, then we believe that we are making decisions based on that. And also at the point where someone has a disagreement, we can as well fall back, take the person through the processes which give birth to the kind of decision that is based on the insights that we have from the recording.
Okay. Now,
I have a lot is hidden within one word. Gaining. It's more study. And that study happened immediately afterward because that excited the world. Like, here is something threatening because chaos in a world that solution was chopped up in like 2 months of it. And about by the end of April, another hospital, this one was in France, had invested over 100 people in the study, and it found hydrochloroquine ineffective. So within April was the first study that showed promise, and between March, end of March and end of April, the first study that showed promise, hydrochloroquine was off the table. But here in Uganda, we were excited about hydrochloroquine because chloroquine is a drug that equatorial countries know how to prescribe. They know how to apply it. As in, doctors know that in a population, some people will be allergic to it. They know that tests for it. We are good to go when it comes to dishing out chloroquine. So we got excited. Like, well, we have chloroquine works. And in Uganda, our national hospital, it was touted. And this was, forgetting that, it was, by the time we got the first 10 COVID victims or COVID patients, the workings of chloroquine had been discounted. It was ineffective. But we went on and they looked at the patients, everyone, I remember because we got to 56 patients, all fully recovered, and they were being given, a majority of them were being given chloroquine, and had the president in May, June, July, everything, like, oh yes, our doctors are getting chloroquine, are using chloroquine, and they're successful. Doctors in the lab are saying, oh yes, this is successful. But as I started, they did not look at the origin of where information came to prescribe to try a chloroquine. And from their study, who can bring them? Patients were coming in, they were testing positive, and they were coming out at 100% rate. Obviously, once. Then something happened in October. We got away. Now that is the solution. Suddenly, it stopped working. Now what this tells you is that our medical field is scientifically literate. This is shocking. Is that how can the National Referral Hospital keep prescribing a medication that has come through a process of thinking? They were not part of that process of thinking. The results came in, they were discounted, and then they kept along until when the reality check has done. Or you can, the best conclusion you can come to is that you can, if you are scientifically literate, you can go along with your job if you study the sciences. That is until we make a huge mistake. Luckily for us, we know how to describe problem, we know how to deal with the people who are allergic, we know how to deal with those things, you know that those things that excite us. It wasn't a catastrophe, but it could easily have been. But the good thing is that not everyone is scientifically literate. In December 2020, we had a few of them who got together and did a study, what we call a clinical study. Patients come in, you are assigning with some chloroquine, you are assigning some basically nothing. And they found it to be ineffective, yet level. And they published their results in 20, I think it was December 2021, after year. But to my knowledge, there has not been a national, I have not seen any results that say, oh, this was a big mess up. How would we even think like this? And that is the reason why, for today, I chose to speak about, or to highlight the effectiveness of being scientifically literate. Because scientific literacy allows you to express your uncertainty. Scientific literacy tells you, like, say, hey, you can be, evidence does not have to be absolute. You can say, oh, according to this information, it is highly likely that this will happen. It is 80, results show that 80% of this will happen. And it also tells you that, it also informs you that you have to backtrack. You have to come to a cause. As in, the cause is more important than an association. As in, if you are associated with a good result, maybe you're not the most influential person who led to that result. But if you're the cause of a good result, then all the money should be given to you. So, with that, I invite your participation. What holds this as a definition of data science?